Hello, in this short video we are going to investigate together the following A+ level problem. It's a problem on the topic of differentiation rules. If f of x is this function, then f prime of pi over 24 is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct solution to the problem. Okay, so this problem is also a standard problem in differentiation. A function is given, you're supposed to calculate the derivative of a function at pi over 24. So the first thing comes to mind is to differentiate the function and then replace x with pi over 24 and try to simplify if possible. Of course, this will always work, but as you see here, this will be very tedious because this function is a product rule. This is a function multiplied by this function, and if I want to differentiate directly, I have to use the differentiation rule, so the product rule should be applied here. But when I want to differentiate this one, I have to differentiate this one using the product rule, this one using the product rule, and in order to differentiate this one using the product rule, I have to use the chain rule here. So if you are patient and you don't make mistakes, of course your answer finally will be correct. But is there any better way to do it? Yes. Sometimes we don't have to start with the given form of the function. We can simplify the function first and then continue. So this is one of those cases. So it is not hard to see that between these two I can factor sine x cosine x out. Yes. So the first thing that I will do is to rewrite my function in a different way. I factor sine x cosine x out from this pair of brackets, and then what is left in the first one is cosine x squared minus what is left in the second one is sine x squared, and for the time being I copy and paste the last term cosine 4x. Okay. But this combination should look familiar to your eyes. This is the famous double angle formula for cosine. So this can be written as cosine 2x. This combination is also in trigonometry, is very famous. If we have a 2 here, 2 sine x cosine x is the formula, double angle formula for sine, so it's sine 2x. But now we do not have these 2, so this is not exactly sine 2x. It is half of sine 2x. So what I will do, I will write 1/2 sine 2x. Okay, so let us write again what we have. So f of x is equal to 1/2 sine 2x cosine 2x cosine 4x. I hope now you see what the pattern is. Again, here, this reminds you of the double angle formula for sine. Yes, here we have sine of an angle times cosine of an angle, exactly like we had here. But the problem here is x is now replaced by 2x. So if it was 2 sine 2x cosine 2x, the answer would have been sine double angle 4x. But now we do not have a 2 here, so this means that I have this is equal to 1/2 sine 4x. So I will do that. So this is 1/2 sine 2x. Sorry, sine 4x. But now let us see what happens. This becomes 1/2 times 1/2, so it is 1/4 sine 4x cosine 4x. But that is exactly the same idea, yes? So you write it as 1/4 instead of sine 4x cosine 4x, you can write again 1/2 sine of double angle 8x. So this means that this becomes 1/8 sine 8x. So this means that your function, actually f of x, can be simplified a lot, and it can be written as 1/8 sine 8x. And now you see that differentiation of f of x is extremely simple. If I differentiate it, 1/8 is a multiplicative constant, so I pull it out. The derivative of sine becomes cosine of the angle, but according to the chain rule I have to multiply by the derivative of 8x, which gives me 8. But now this 8 will be cancelled by this 8, and the derivative is simply cosine 8x. But the problem is asking you about f prime of pi over 24. So this means that in your derivative you replace x with pi over 24. So it becomes cosine 8 pi over 24, which can be simplified to pi over 3, but cosine of pi over 3, cosine of 60 degrees is 1/2. So the answer to this problem is 1/2. And you see that option A is the correct answer to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.